Hello YouTube viewers, welcome to my show Rocket Monday. In today's episode we're going to talk about NASA's Mars helicopter design. So let's dive right into it. So what is happening here is basically they want to fly on Mars. Now, the carrier mission for this is Mars 2020 rover, which is, if you think it looks like Curiosity rover, because basically the more or less the whole structure is from Curiosity rover. The only thing is they learned that rover's wheel takes too much damage, so they have reinforced the wheel. That's the only thing major. Of course, the payload has been changed, but the core structure is the same. It's like if it ain't broke, don't fix it. So that is the main mission. On this mission, they're gonna be piggybacking this helicopter. So this is the main mission. This is the main budget item. This is a piggyback mission. Now, this the rover itself is nuclear powered, as you can see from the thermoelectric generator. Plutonium decays as a heat, as a heat source, and then it gives off thermal radiation. The thermal radiation is converted using thermoelectric generator into electricity, and voila. But that is very big, very heavy, and very clunky, so that cannot be utilized for a flying object. So this helicopter is basically 100% solar powered, 100% independent from this. So that's the idea, flying on Mars. This is the ticket item. This is the story. Then the question becomes why we are doing that. Well, you have to understand that this is not something that they are putting too much faith into it, because by definition this is a technology demonstration. They want this to work, but this is a demo mission. This is the first time somebody is truly trying to fly powered flight on any other planet, because you have to understand the only other experience we have is from Venus and from Soviet Union era, and that was like on a balloon. Like, again, it did work, it did quote unquote fly, but it was not powered flight. This is a powered flight system. So this is a technology demonstration mission. This is like this is for engineers to, like, okay, we had a hypothesis, we had a theory, we built our thing, let's test it out in real world. And you have to understand, real world we can't simulate. No matter what you do, you can't stimulate one third the gravity on Earth. So you have to test it on Mars. So all things considered, this is a technology demonstration mission. Now, if you read the NASA's directorate about it, it's basically classified as high risk, high reward. If it works, awesome. If it does not work, not too much of an issue. Basically, they are not selling this like, oh, we're gonna send this and it's gonna fly. It's like, hey, this is a test mission. It could work, it could go awesome, but it could fail also. And then the question becomes, okay, what will they gain out of this? Why they are putting the best and brightest and that amount of money into it? What will they gain out of it? First thing you have to understand, rovers are ludicrously slow. They will make our snail look like Flash, Barry Allen, fastest man alive, because rovers have been running very slowly. Like, they take years to achieve a few kilometers. So compared to that, this will be super fast. On top of that, this is a demonstration mission. So this is classified as less than 2 kilogram. That's the payload, like the total weight. So they have other designs also. If this works out, if they learn from it and improve the design, they have targets for like 5 kilogram and 10 kilogram. Now those puppy will have real big deal things. So that is why they are doing it. First, flat out right now, if this works right now with current iteration, they will gain enormous speed for 2020 rover. That's an awesome advantage. Now again, if this works out and they learn things from it, like how what are the problem, how the heating characteristics happen, how the cooling characteristics happen, all those knowledge will allow them to make even bigger rover, and those puppy will be like independent mission on themselves. So that is why they are doing it. Then let's understand the certain problems that we face when you want to fly on Mars. What is the primary problem that you have to deal with? Basically, Martian atmosphere. It is like one hundredth of Earth. Basically, it's almost partial vacuum. So the problem with that is basically atmosphere is directly proportional to how much energy you have to spend in order to fly. Now on Earth we have very thick atmosphere, so we got it. Like, you can have a very small wing and you can fly, or you can have a very small rotor, rotate it fast enough, it will fly. But on Mars, there is simply not enough air molecule for you to get your basically whatever lift. So what you have to do, either make it very big, make it spin very fast. And again, even if you are talking about spinning something fast, you can't spin it beyond a certain point. Basically, if you are making a helicopter, drone, or whatever have you, the tips should not go supersonic. So you can't have like, okay, it's a big thing and we're gonna spin it at 20,000 rpm. The tips, the moment the tip crosses supersonic, the airflow will become gibberish. So again, you have certain limitations. Somehow you have to figure out enough airfoil area, you have to figure out enough basically momentum and all that, so you can get a lift due to the Martian atmosphere. And the fact that you have a lower gravity does not help that much. So that's the first problem. The atmosphere itself, that will affect your design language, basically how you're going to make the wing, how you're going to make sure what kind of RPM we are talking about. Because you have to understand, on Earth, a helicopter can easily fly at like 600 to 900 RPM. This puppy, they are starting at like 2600. Now, again, you need power for this kind of thing. So low solar power is also another problem. You can't power this from a nuclear system because simply it's too heavy. And in terms of solar panel, the problem is there is not enough solar flux on Mars itself. So the same solar panel that they have here, if you put it on Earth, you're going to get a lot of power, but the moment you put it on Mars, you will get like barely 3 watts of power. So power is another issue. On top of that, let's say you figured out the power issue, you figured out the atmospheric issue. The final nail in the coffin is the cold temperature. Basically, the moment night starts to, like, nightfall begins, the temperature goes down. Now that's not an issue for electronics that much. However, your battery, your chemical battery, they did. If that temperature drops to that low, they did. Now, generally, Curiosity rover does not have to worry about that, simply because they have giant radioactive material heating them up. So for them, that's not an issue. And in other rovers, we literally used to have like small heating elements, which are just radioactive isotope. That's it. It's just acting as a heating element. But again, those are heavy things. We generally do that very sparsely. Or you have to use electrical power itself as a heating element. Again, that will consume power, which will again backfire to that limited solar problem. So these are the 3 core problems. Somehow you have to design a basically lifting body mechanism. Somehow you have to have enough power for this, and somehow you have to make sure you don't freeze to death. Then what did NASA do to solve all this problem? First, they put the solar panel on top. Simple one. Now, if you think the solar panel is very small, they have to make it small, otherwise it itself will be pulled down by the rotor, draft itself. So because of aerodynamic reason, they cannot just make it YOLO big. So that is the first power source. Then they are utilizing what we classify a coaxial rotor, basically counter-rotating props. Now you might be like, why they are doing that? Well, in normal helicopter, you have to deal with, if you have one rotor that is spinning, it will, action equals reaction is rotating clockwise. Your helicopter will end up rotating like basically top counterclockwise. So you can't have that. So in Earth scenario, we generally utilize basically tail rotor. Now you can't have that luxury here, so we are simply putting 2 of them. Drone can simply do that simply because it has 4. So 2 will be rotating clockwise, 2 will be rotating counterclockwise. But here they don't have such a luxuries, because I told you the wingspan has to be huge. Basically the lift area has to be huge. So they are utilizing coaxial system. Again, it has certain advantages, but the main advantage is that your payload will not start spinning like a top. So that's the first advantage. Now the whole idea with this is, like, once you land it basically on Mars, it's gonna take whole day to charge, and it's gonna use electrical heater to make sure it can survive the night. Otherwise, one night and it's dead. That you have to understand, that winter is the biggest problem for them. Like, winter is really coming for them every night. So that's the design. You put solar panel on top. That should, best case scenario, give them 3 to 5 watts of power. They have counter rotating. The diameter is quite huge. 1.2 meter is huge. So many people were like, hey, why not send 2 or 4 of them? Yeah, 1.2 meter. And this is not a folding mechanism. So it's quite a huge material. And then you have to understand, even if they send, like, they won't get too much, because you have to wait whole day to charge it. And the heater is also consuming too much power. So that is why, like, if you think this is like very bare bone structure, like very minimal scientific payload, that's the whole point. This is just a testing. Can we fly something on Mars or not? So what's their goal? Like, let's say they finally landed on Mars. So you have to understand, because of its huge size, it has to be carried under the belly of the rover itself. So basically, rover is going to drop it and move away from it, basically on top of it, away from it. So that's the first stage of the mission, hoping that rover itself does not crush it or it lands properly. So once you have that, it has completely autonomous system. Basically, there is a lot of computational core put into this to make sure it can fly on its own. Because at first, like, the idea was like, what if rover did the heavy computational task, but problem was like, due to latency, lag. Yes, I'm talking about helicopter to this. You have to understand that still takes an insane amount of lag and latency, and because we don't have enough feedback on that, like, we do not know how it's supposed to work. Unknown data point. So computer needs to react like around 100 hertz or 200 hertz. At that speed, the radio energy requirement would be too high. So they are like, okay, put everything on board. And it also has a like 13 megapixel camera, which is just there as a like a good high resolution camera. Is just enough for like give something idea. Like, the image will be sent to the rover will send it to satellite will send it to us, and then we'll be like, okay, rover should go here to check it out or not. So the system is completely autonomous. However, it cannot communicate to satellite. It does not have that kind of power. Now, what they're aiming for is like full day of charge. They should get 90 seconds of flight time. Only 90 seconds. And I'm not even sure that they're gonna push it to that much, because at 90 seconds they have very small buffer, because batteries have a scenario what we call brownout. Basically, if the voltage drops too much, you cannot charge it again. So the 90 seconds is their safety margin. Like, they will fly at like 80 seconds, and around 80 seconds they will like, okay, start to land. So 90 seconds is the target. Now, how much distance they're supposed to cover? Their best case estimate is around 600 meters. That is why I said like it is ludicrously fast compared to rover, not compared to Earth drone or anything like that, but compared to the Mars rover itself, it's ludicrously fast. So it can do a lot of coverage before rover even got to 1 kilometer. So that is why like that is the good case scenario. If this works out, the camera works, everything works, they can literally scout out much larger area than any previous rovers. And they have their solar panel, their estimate is around 3 watt of power for 12 hour continuously they should get. So these are the goals. Like that is why I said like this is not the ticket item. This ticket item is Mars 2020 rover. This is just like, okay, let's try this also. If this works, awesome. If it does not work, again, high risk, high reward. That is why the risk was there. So this was my presentation on basically Mars helicopter. I hope you liked it, learned from it. In that case, please click the like button. If you didn't like it, didn't enjoy it, I would urge you to press dislike, press it twice to show me your extra disappointment, and please leave a comment because I reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.